Hello students, this is Sujata coming with class 10 ncert SSC Maths with Sujata G. Now students, let us see the chapter 3 arithmetic progression for the 10th SSC and the subject Maths 1. Now here that there are the four topics. First topic is sequence, second one is the n term of an AP, third one is the arithmetic progression, and fourth one is the sum of n terms of an AP. Okay, so let us study about the first topic, that is the sequence. So now here the sequence, first we have to define the sequence. We know very well about that is the sequence, but here we define it, that is a set of numbers where the numbers are arranged in a definite order. It's called a sequence. So here there are the series of the number, but that numbers are in a definite way it can be arranged, then we can say that it is a sequence. So example, we can take the example here, that is first one 4, 8, 12, 16. So here there is a definite arrangement, and that arrangement is that this is the table of 4, and the table of 4, that means there is the next number is increased by the 4, next number is increased by the adding 4. So it is a sequence. Now the second one 2, 4, 8, 16, 32. So now here also there is a specific arrangement, students, and that specific arrangement is that the if you 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So this way we get the next number. Okay students, and here third one, that is 1 upon 5, 1 upon 10, 1 upon 15, 1 upon 20. It is here also there is a definitely arrangement of the series of the numbers, and that means we have called that this is a sequence. Okay students, now get this problem. What is the sequence and how can we define it? Now the next one, that is the terms in a sequence. In a sequence, order terms are represented as T1, T2, T3, comma dot 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 up to Tn. Okay. So here in a sequence, in general, sequence is written as T of n. Okay. In the curly bracket, T of n. Now, if the sequence is infinite for every positive integer n, there is a term T of n. Okay. If there is a condition that if there is a sequence and that sequence is infinite, then we can say that there is a term T of n, students. Okay. Now here see that there is a some activity. So see the activity 1. Some sequences are given below that show the position of the terms by T1, T2, T3, comma dot dot dot. Now here we have to recognize T1 means the first term, T2 means the second term, T3 means the third term. Okay, so we have to show the position. So first one 9, 15, 21, 27. So this is the sequence and we have to represent it. T1 is equal to 9 because this is the first term. T2, that means the second term, which is equal to 15, and the T3 means the third term, that will be equal to 24, and T4 is equal to 27, which is the fourth term. Now here in the second example 7, 7, 7, 7. So here all the terms are 7. So we call it as T1 is equal to 7, T2 is equal to 7, T3 is equal to 7, and T4 is equal to 7. Now in the third example 2, minus 6, minus 10, minus 14, comma dot dot dot, students here. So now here T1 first term is equal to minus 2, T2 second term is equal to minus 6. Here we can write here, students, minus 6. Okay, here we write that is the minus 6. Okay students. See here we write here minus 6 and T3 as a minus 10. Okay, and as well as we can write T4 is equal to minus 14 also. Okay, so such a way we can represent the position of the terms by T1, T2, T3. Okay. Now here see that the next term is obtained by adding a particular number to the previous number. Such a sequence is called an arithmetic progression, students. Now see about what is the arithmetic progression. If you clear out the concept sequence, then we can recognize, we can identify what is the arithmetic progression. Okay students, that means here the next term is obtained by adding a particular number to the previous number, then such a sequence will be called as the arithmetic progression. Now here student, see the activity 2, that some sequences are given below and check whether there is any rule among the terms and find the similarity between the two sequences. Now here fill the empty boxes suitably. So the first example is 1, 4, 7, 10, 13, comma, dot, dot, dot. Okay, so now here see the terms are arranged in this way: 1, 4, 7, 10, and here we have to write the next term. Okay, next two term. That will be here. Suppose 1, there is a first term 1, that is a T1. If you add 3 in this one, then you get the next number, that will be the 4. If you add plus 3 in the 4, then you get the next number 7. If you add 3 in the 7, then you get the 10. Okay, the next number. If you add 3 in the 10, then you get the next number, and that is the 13. Okay, and if you add the next number, if you add 3 in the next number, then you get the next number. So this way 13 and 16 are the next two numbers. Now here 13 is given, so now the next number is that 16 plus 3, that means the 19. So this way we can arrange the sequence and such a way that we get the next term by adding the any definite number to its previous number. Then we get a sequence, and that sequence is known as the arithmetic progression, student. So here we say that this sequence is an arithmetic progression because a definite number is added in the particular number. Okay students, now let us see the next one example. Students, here see the next one example. Here the next one example, 3, 3, 3, 3. Okay, now here if you added 0 at each time, then you get the next one number, students. Okay, so here also we can write the 3 plus 0, here also 3, then here 3 plus 0, getting the 3. Okay, so this way we get the series of 3, and that a definite number, we have to add a definite number in the previous one, and then we get the next number. So that means this sequence is called as an arithmetic progression, students. Okay, so let us see the next one example, then you clear out the concept arithmetic progression. Okay, so see 6, 12, 18, 24, comma, dot, dot, dot. Now here we arrange these 6, 12, 18, 24 this way, and if you add plus 6, if you add 6 in the previous one, then you get the next number. Okay student, so here we can get the next two numbers. That means here we added 6 in the previous one, then we get here 30. 30 plus 6, that means the 36. Okay, so 30 and 36 are the next two numbers of this sequence, and there is a definite number. That definite number you have to add it in the previous one, so that means it is an arithmetic progression, students. Okay, so now see the next one example, students, here that is 4, 16, 64, comma, dash, dash, dash. Now here if you multiply 4 by the previous number, then you get the next number. If you multiply 16 by 4, then you get the next number. So here after multiplying, you get the next number here, students. Okay, not adding a definite number, you multiplying any number or a definite number, then you get the next number. Okay student, so this way we can find out the next two number, that is 64 fours are, that means the 256. Okay, then here 256 multiply, that 256 multiply 4, that means 2, then 1024. 1024 multiply 4, that means the 4096. Okay, so such a way we can get the series of the sequence. Okay, the number of the sequence. But here, if here a definite number is multiplied in the previous one, so such a sequence is not an arithmetic progression, but that sequence should be called as a geometric progression. Okay, that such a type of the sequence is called as the geometric progression, students. Okay, so we can say that there are the two types of the sequences, that is the arithmetic progression and as well as the geometric progression. Okay, So this is the geometric progression, students. Okay. Now here, student, see the next. That next one is -1, -1.5, -2, -2.5, students. This is an example. So here, if you add -0.5 in the previous one number, then you get next one number. That is -1 plus -0.5, then you get the next number -1.5. If you add here -1.5 plus -0.5, then you get the next one number. So this way, this is the arrangement of the sequence. So here, that the next number will be the -3 here. Okay, next one number will be -3. That is -3.0 means the 3. And the next number will be that -3.5, students. Okay. So such a way the definite number is added in the previous number, and so it is an arithmetic progression. Okay, student. So such a way we identify which one is the arithmetic progression and which one is the geometric progression and which one is not an arithmetic progression. Now here in this example, students, see cube of 1, cube of 2, cube of 3, cube of 4 here, student. So now here only the cube of 1. So there is no relation in between that. Suppose the cube of 1, that students, cube of 1, we here write that cube of 1, that is the 1, cube of 2, that is the 8, cube of 3, that means the 27, and the cube of 4, that means the 64. So we couldn't say that there is a relationship between the consecutive two numbers. So we say that it is neither arithmetic progression nor geometric progression. Okay. Students, thank you for watching our videos. Achieve your success with us. I am sure that you will get 100% success in maths. So watch our videos continuously, regularly, like our videos, share our videos to your friends.